Hi, my name is Adam Wentworth, and this is a Solidworks tutorial on how to make something called Involute gears. I'm not going to write out this whole thing. Involute gears. Alright. Okay, so this was based off of a GrabCAD tutorial that looks like this. But the changes that I made to this tutorial are making the model parametric. So now you can take this one model that you made and adapt it to whatever application that you're going to use it in. So in gears, I think is a pretty common engineering application for CAD. Okay. So what is an involute gear? An involute gear is basically gears that will transfer their load between teeth very smoothly. So you have a, let's see, the contact between the teeth is at a single point. So you have, let's see, smooth transition of power with minimal speed or torque variations, right? And what is involute? So basically, there's a wiki on it with lots of math, which is not great, but basically involute is approximating a path followed by like a string as the free end of a string if it is wrapping around a circle while it's fixed at one point. So it's kind of like the path of a tetherball as it goes around a pole. Right, so the string is being wrapped around the circle, and you're following the free end of the string as it goes around that circle. In this example, you have a very small circle, the cross section of this pole. In our model, this free end that wraps around the circle is going to define the one side of the gear tooth. So you'll see that as we go. Okay, so we'll start a new model in Solidworks. So I'm just going to choose to do a new part. And then we're going to set some equations. So if you don't see equations by default, you can right click, hide show tree items, and then equations is going to be here. By default I show them because you'll use them a lot in the certification exams. And that's what we're going to use to make this model parametric. So let's skip over to the model that we've made before to show you what equations we're going to throw in there. Okay, so we have a couple of variables. First is called P. This is the pitch diameter, or it's not kind of the absolute outer diameter of your teeth, but it's kind of like the midpoint of the tooth. You're going to have sort of an outer diameter defined later by this P plus 2 times M value. So don't worry about that. So we'll just create a variable called P, and you can copy these numbers if you want. Throw a 2 in here. Okay, your variable called N is the number of teeth on your gear. So you put 16. N is called a module, and it kind of defines the shape of the tooth. So it's going to be P divided by N. So you can write equations in here as well. And the variable A is called a pressure angle. Put that in there. And most typically it's 20 degrees, and it can vary maybe by a couple of degrees, but not too much. And so this will kind of define a maximum load that you can apply on the tooth. If we look back on here, we have pressure angle. So it basically says it varies according to the position of the shape. Stock gears have 20 degrees, and increasing the angle increases the width of the base and has greater strength and load carrying capacity, and decreasing the angle provides lower backlash, smoother operation, and less sensitivity to manufacturing errors. So it's kind of like better tolerance to defects, right? So go back here. Okay, so once we have our variables here, just hit OK. Oh no. Alright, let's try to close some stuff. Okay, now that we've got these equations listed, we are going to start our sketch. Okay, so just go up to Sketch, Front Plane, and we're going to make a circle. And this is going to be a construction circle. Okay. And this circle dimension is going to be equal to our pitch diameter. So if we right click and drag up, we get a shortcut to our smart dimension. Click on the circle and then click outside the circle and hit the equal sign, go to global variables, it's equal to P. And just hit enter twice or 3 times, click the checkbox. Okay, and now we're going to use our pressure angle with some construction lines. So click on the line tool for construction. Start from the origin, click once, go vertical, so you see these yellow boxes pop up with vertical relations. Click there. And I'm going to double click off the side to get rid of my line. I'm going to click up here. Make sure it passes through this point and contacts the circle on this side. Okay, and then hit escape to get out of the tool or double click. So now you'll notice if I hit escape I get out of the line tool. I can drag this free end, and what I want to do is make sure that this line lines up with this endpoint. So if I hold Control or Shift and click this line as well, I can make that coincident and it will line up. I want to make sure that I have a 20-degree angle from the horizontal. So I can also just make another construction line horizontally from this point. You want to make sure that you don't accidentally hit this midpoint because it's not the same. Okay, then we want a horizontal relation on this line, so the yellow box is horizontal. Click that, hit escape, and let's dimension the angle between this as our pressure angle. So hit smart dimension, click the 2 lines, put the angle label in between, and do equals, go to global variables, and make that our pressure angle, which is 20 degrees. Okay, you'll notice when we do this, when we use our equations, we have a sum symbol here, which shows us that it's using our equations or our variables we've defined. Okay. Now what we're going to do is we're going to take a construction line from our origin, and we want to make it coincident with this line. Hit escape. And we want it at a very specific angle. So we actually want these 2 lines to be perpendicular to each other. So we're going to select both of them. So click, shift, select this other line, and this relation will pop up either here or down here. You can click either and make them perpendicular. You'll see it'll snap to. And hit escape. Okay, this is going to define the radius of our interior circle. So we're going to draw another circle that matches this line. Okay. Next thing we're going to do is dimension the distance between this point and this point. So smart dimension, click those 2 points. Make sure that your dimension tool lines up parallel to that, so you can click that. Right. And once we escape the tool, that's going to look gray because our circles out here are fixed, and so this dimension we cannot define. It is predefined by these fixed 2 points, so it's showing us that it's gray, which means we can't change it. Okay. So now what we're going to do is start plotting some points that will show us the edge of the tooth of the gear that's up here. Right? To do that, we're going to make some center point arcs. A center point arc you first define by the center point, starting point, and the ending point. So we are going to click the origin as our starting point, this point as our starting point of the arc, and we can see maybe this is our ending point. Right? We actually want it to go the other way around, so let's get rid of this interior circle. We can see. Actually, let's make this a construction. Okay, so we want our arc to go left. Let's see.